Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL November 2021 paper 1 and today we will be solving question number 10 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 10. The maximum mark is 16 and it says a particle P moves along the x-axis. The velocity of P is v meter per second at time t seconds, where v of t is 4 plus 4t minus 3t squared for t ranging between 0 and 3 both included. When t equal to 0, P is at the origin O. That means the displacement is 0 at the starting moment. Okay. And subpart A is having two more subparts I and II. The I says find the value of t when P reaches its maximum velocity. So when P reaches its maximum velocity, the acceleration should be equal to 0. Okay, because acceleration is the derivative of the velocity expression. Okay, so let us get the acceleration expression. AI. Acceleration, it is also a function of t. So this is dv dt, which is equal to 4. It is a constant. So when differentiated, it will be giving us a 0. 4t will be giving us 4. And minus 3t square will be giving us minus 60. This is equal to 0. Okay. So therefore, 6t is equal to 4 implies t equal to 4 over 6, which is 2 over 3 seconds. Okay. So the answer is 2 over 3 seconds. I show that the distance of P from O at this time is 88 over 27 meters. You can see that when what I have said that when P is having the maximum velocity, E is equal to 0, you can just add this line at the beginning if you want. Okay. For this I, not for II, obviously. So now coming to the II part. Notice this word distance. Show that the distance of P from O at this time, that is 2 over 3 seconds, is 88 over 27 meters. Now, how do we get the distance? If we integrate the velocity expression, we will be getting the displacement. And the distance and the displacement, they are not always the same. If the particle turns, after the particle has turned, it has changed its direction. The displacement and the distance, they do not have the same value. Okay. So, we may try to first of all find out when is the particle changing its direction. Is it before 2 over 3 seconds or after 2 over 3? Because you see, when t equal to 0, v is equal to 4. Positive number, that means the particle is moving towards the right. When it is it changing its direction and when is it starting to move towards the left? We have to find that first. Okay. So let us, for that, we equate this expression to 0 and we get, I'm writing minus 3t square first of all, plus 4t plus 4 equal to 0. And I'm factorizing the left hand side, so it will be minus 3t squared plus 60 minus 2t plus 4 equal to 0. So this is, if I take minus 3t common, it is t minus 2 and minus 2, t minus 2 equal to 0, which is giving us minus 3t minus 2 and t minus 2 equal to 0, which implies that if negative 3t negative 2 equal to 0, that means negative 3t will be equal to positive 2, or t will be equal to negative 2 over 3. So t is equal to negative 2 over 3, or t is equal to 2 seconds. So definitely t cannot be a negative number. So t is equal to 2 seconds. This is the time when the particle is changing its direction. So now we are sure that at time t equal to 2 over 3 seconds, the particle is still moving towards the right. It has not changed its direction. Therefore, the displacement and the distance, they will be having the same value. Okay. So what do we have to do? We have to, in fact, integrate the velocity expression. So S of t is equal to the integral of v of t expression with respect to t. So this is giving us, okay, let me write the expression as well. 4 plus 4t minus 3t squared dt equal to 4t plus 4t squared over 2 minus 3 t cube over 3 plus c. Okay. And c equal to 0, since s equal to 0 when t is equal to 0. Okay. Therefore, s of t equal to 4t plus 2t squared minus t cube. Therefore, s of 2 over 3 is equal to 4 times 2 over 3 plus 2 times 4 over 9 minus 8 over 27. So this is, if I take the common denominator as 27, because they are having the common denominator as 27, so I have to make the common denominator 27. So in order to have the denominator of 27, we have to multiply the numerator and the denominator by 9 in this case. So 4 times 2 is 8, 8 times 9 is 72. This is 9, 9 times 3 is 27, so 8 times 3 is 24. Plus 24 and minus 8. So this is equal to 72 plus 24 is 96. 96 minus 8 is equal to 88 over 27 meters. Okay. Shown. And we have solved the subpart A completely. Moving on to subpart B. Subpart B, sketch a graph of V against T. T is always drawn along the x-axis, clearly showing any points of intersection with the axis. That means the y-intercept and the x-intercept. And it is containing 4 arcs. So, and this is the velocity expression that has been given to us. T is between 0 to 3 and the velocity expression is 4 plus 4t minus 3t squared. And we had found the t value when v is maximum equal to 2 over 3 seconds in subpart A. Okay. We have not found the corresponding v value we have to find because we had to obviously show the vertex point. So let us first of all get the vertex because I have written 2 over 3 for t rather. So let us first of all get the vertex value of the velocity. So it is v of t. Instead of t, I am writing v of 2 over 3. So this is 4 plus 4 times 2 over 3 minus 3 times t square. So it is 4 over 9. 4 plus 8 over 3 minus 4 over 3. 8 over 3 minus 4 over 3 is 4 over 3. So 4 plus 4 over 3. 4 can be written as 12 over 3. Plus 4 over 3 is 16 over 3. Which is 5 and 1 over 3. So the vertex will be 4 over 3 and 16 over 3. Okay. So the y-intercept will be when t equal to 0, v equal to 4. So the y-intercept is 0, comma 4. And the x-intercept, we have found the x-intercept in our last question, AII. We were testing whether the when is the particle changing its direction. And we had seen that to be equal to t equal to 2. So we have to find t equal to 2 and the y value will be equal to 0. So we don't have to find exactly what will be the y value or the velocity value. So it will be the x-intercept is 2, comma 0. Okay. So we have got when t equal to 0, v equal to 4. This is the x-intercept. We have got the vertex. One more thing has to be found out before sketching the graph. What is the value of v when t equal to 3? Because this is important. T is between 0 to 3, so you have to get the velocity values for t equal to 0 and t equal to 3. And important features, when is the graph changing, velocity changing from positive to negative. That means the particle is changing its direction. Where is the velocity maximum? Every detail you have to get. Okay. So what is the value of v when t? Let me just find it. Try to find v of 3 is equal to 4 plus 4 times 3 minus p times p square. So 3 square. So this is 4 plus 12 and 3 square is 9. 9 times 3 is 27. So it is minus 27. 4 plus 12 is 16 and this is 27. So 16 plus 11 is 27, right? Because it is paper 1, you cannot use your calculator. So this will be equal to negative 11. So another point that we are having will be p comma negative 11. This point is very important. You have to get the ending point. Okay? Now we can sketch the graph. We don't have any part on the negative side of the t-axis. So it's fine. And we'll be going at this is a rough sketch, or I should be not taking this in fact, because t will not get extended to the left. Be taking this. Fine, this is fine. And we have to this one maybe 2, this is 4, 6, 8 and so on. Fine, and this is maybe 1. We need up to 3. This is 2 and this is 3. This one will be negative 4. This one is negative 8. This one is negative 12 and so on. Okay. So now we are in a position to plot the points. First point will be over here. The y intercept, the x intercept is 2, 0, so it will be here. What is the vertex? 2 over 3 maybe over here. So 2 over 3 and 16 over 3 is 5 and 1 over 3. So 5 is over what? Where? 5 is over here. So maybe over here. Where over here? Okay. Let me write the coordinates. It is 2 over 3, 16 over 3. Okay. And one more point, 3, negative 11. Fine. It is over here. Okay. So this is a parabola starting from over here. Okay. So, and this one is the t-axis in seconds. This one is the v in meter per second. So this is the sketch. And we have shown any points of intersection with the axis. We have shown the y-intercept. We have shown the x-intercept. So we are done. Okay. Let us move on to the part C. Part C. Find the total distance traveled by P. It contains 5 marks. Now, this is the velocity expression. 4 plus 4t minus 3t square, and t is ranging between 0 to 3, both included. And we have sketched the graph of v versus t, and we have seen that the velocity is moving from positive to negative at t equal to 0. That means the particle is changing its direction. Before it was moving towards the right, now it starts moving towards the left at t equal to 2 seconds. Okay, so, and they have asked for the distance, not the displacement. Therefore, we had to take two regions separately. One region when the particle is moving towards the right, another region when the particle is moving towards the left, and we have to add those two. And when the particle is moving towards the left, okay, let us first of all deal with the region where the particle is moving towards the right. Okay, so we have to get the distance. When the particle is moving towards the right, the displacement and the distance both will be having the same value. So we will be finding the displacement value by integrating, and we will be having definite integral. The time will be ranging between 0 to 2, because that is the time interval where the particle is moving towards the right. Okay, so distance traveled when the particle is moving towards the right is equal to 0 to t, is 0 to 2 rather, and the integral of this 4 plus 4t minus 3t squared dt. We have once done this integral in AII. We are doing this integral again. So it will be 4t plus 4t squared over 2 minus 3t cube over 3, and this is between 0 and 2. Okay, so this is 4 times 2, and this will be cancelling, so it is plus 2 times 2 square minus 2 cube minus 4 times 0 plus 2 times 0 square minus 0 cube. Okay, so this is 4 times 2 is 8, 2 square is 4, 4 times 2 is again 8, and this is minus 8. This is 8 meters. Okay. Now the particle starts moving towards the left. So distance traveled towards the left, or when P starts moving towards the left. Equal to. Now, if you think of the graph was of this shape. This was 2 and this was 3 and negative 11. So this portion is below the x-axis. Okay. And whenever we have to find the area below the x-axis, obviously the distance will be positive. So what do? We prefix a minus sign. We will be prefixing a minus sign. That is what I was saying, that, okay, first of all, let us deal with the right side. When it is moving towards the right, then let us come to the left portion. For the left portion, the only difference, of course, the boundary values will be different. And another difference is the integration will be having a minus sign in front. So now it is from 2 to 3. 2 to 3 and 4 plus 4t minus 3t squared dt. I don't have to integrate again. It is the same expression. So it is 4t plus 2t squared minus t cubed. There should be a minus sign in front. It is 2 and 3. This is 4 times 3 plus 2 times 3 square minus 3 to the power of 3 and minus 4 times 2. And 4 times 2, this part was equal to 8. But anyway, I can write it. If you are getting confused, I am writing it. 4 times 2 plus 2 times 2 square minus 2 cube. Okay, so this is minus 12. This is 9. 9 times 2 is 18. And this is 27, so minus 27. This is 8, so minus 8. This is also 4 times 2 is 8 minus 8. And this is minus 8, so plus 8. These two will be cancelling, and 12 plus 18 is 30. 30 minus 27 is 3. 3 minus 8 is minus 5, and there is this minus sign in front, so it is plus 5. So 8 meters move towards the right and 5 meters move towards the left, towards the origin. Okay. So 8 meters away from the origin and 5 meters towards the origin. Therefore, total distance equal to 8 plus 5, or 8 meters plus 5 meters, equal to 13 meters. Okay. So students, we have solved question number 10 completely, and thank you for staying with me till the end. I'm Nilanjana Sanyal. I tutor IB Math A, SL and IB Math A, HL students from within India and outside India. And I am starting small batch group tuition for IB Math A, SL and IB Math A, HL level students. You're seeing my WhatsApp number getting displayed. You're seeing my email ID getting displayed. If you're interested in joining my group sessions, you may contact me for more details. Okay. And we'll be meeting very soon in our next session where we'll be solving question number 11 of the same paper. So till then, bye.